Hello and welcome to Tech Deals Part 5 of the Ryzen 5 1600X build video series, Windows Performance and General System Overview. Now this is not about gaming. Gaming was in Part 4, linked down in the video description below to the full playlist on this build video series. Furthermore, there's only a couple of days left to enter the giveaway that will also be linked down in the description below. Please be sure you have done so. Now in this video, I'm going to be talking about general Windows performance as it relates to web browsing, using your computer, editing, rendering images, videos, doing file compression, and other tasks. Now I'm going to be showing you some benchmarks up here in the corner in just a second, but I'm also going to be talking in general terms about what to expect from a Ryzen 5 1600 or 1600X, who should consider buying this CPU, and what the alternatives are. Please note all of the benchmarks that I'm using are free to download except for 3D Mark. The 3D Mark graphics benchmark does have to be purchased, but PC Mark 10, the general application benchmark, does have a free version, and everything else has a free version as well. I'm not providing comparison numbers in this video. That's not the aim here. The goal here is for you to run the benchmarks on your own machine to determine, is this worth buying, building, or upgrading to, either through a completely new build or by buying a motherboard, CPU, and possibly system RAM to install into your existing computer. All of the tests you're going to watch will run at stock clock speeds. There's no overclocking going on. The Ryzen 5 1600X CPU has a base all 6-core turbo speed of 3.7, a standard turbo speed of 4.0, and an XFR speed of 4.1 that it auto overclocks itself to. The 120mm liquid cooler was installed, so of course we have no problem with the chip auto overclocking itself, and the system memory was run at DDR4 2666. The first benchmark I'm going to show you is CPUZ. CPUZ is a wonderful utility that tells you all about your computer, how fast your memory is actually running, not just what's reported, the voltage of your CPU, and a variety of other information. There is a benchmark built into it. Please note you have to run the same version of the benchmark for the scores to be comparable. Whenever they do a major version update, the benchmark often gets updated. In any case, we have 450 points in the single-threaded test and just under 3,500 in the multi-threaded test. Now those numbers in and of themselves don't mean anything. You have to compare them to your own machine. It takes 1 minute to run the benchmark. Download it, run it on your machine. Now the single-threaded score matters for things like opening a web browser, watching a video, opening up Microsoft Word or Excel. Now it's true that Word and Excel are multi-threaded programs, but what the average person uses them for is not. You have to be doing some pretty complicated programs in there before you start getting into really heavy multi-core use. Even using Skype and other type programs, working on a PowerPoint presentation, none of that is very processor intensive, and most of it is single-threaded or two-threaded at most. So the single-threaded score of 450 is the one you want to look at on your own machine versus this one to see whether or not this is faster than your current computer. If your computer, for example, scores 225, this machine is twice as fast at processing as yours is. Now that doesn't mean everything is twice as fast. The CPU is twice as fast, and having a faster CPU only helps if the CPU is why your system is slow. It's worth pointing out at this point that if you don't have enough system memory, or you have an old slow hard drive and your computer is really slow to open programs, a faster CPU won't help. If you open 16 web browser tabs at once and you have 4 GB of system RAM, a faster CPU won't help. You need enough system RAM and a fast enough storage medium, such as a solid-state drive, for the faster CPU to be able to do its thing. So don't put this into a 7-year-old computer with 4 gigs of RAM and a slow hard drive and expect to have miraculous results. The numbers you're seeing here are on a solid-state drive with 16 gigs of RAM. Now what about the multi-threaded performance of just under 3,500? Are you wanting to do some video editing, video rendering? Do you want to do some 3D animation? Do you want to do heavy multitasking with like 5, 10, 15 different active programs open at once? Do you want to play games such as AAA games? Many modern games, from PlayerUnknown Battleground to Ghost Recon Wildland to many others in between, will now use between 4 to 6 cores. If any of that describes what you do with your computer, a Ryzen 5 1600 should be the minimum CPU that you upgrade to, 6 cores, 12 threads. It's possible, depending upon your workload, that the Ryzen 7 1700, for about $90 more than the 1600 with 8 cores and 16 threads, might actually be a better long-term deal, although most people are really well situated with the Ryzen 5 1600. The next benchmark we're going to run is CrystalDiskMark. CrystalDiskMark is a disk benchmarking program. Now there are a bunch of numbers on the screen at the moment, but the two lines I want you to focus on are the bottom two lines. Please note that the top two lines are the ones that drive companies love to advertise because it makes them look better, especially the very top number. Now, because this is a solid state drive, what you'll notice is that the top line and the third line from the top are both very high, about 600 megabytes per second. But that's not actually what's important. That's sequential transfer rate. That's the speed you get when you're copying a file, but only from this drive to a different equally fast SSD, not from this drive to this drive, which would run much slower. No, the more important number is the 4K random read speed sequential in the bottom left-hand corner, the 35 megabytes per second. Okay, it's not quite 35, it's just under, but we'll call that 35, it's close enough. Now, why is that number important? Because your average hard drive won't even get a 1 there. In fact, the average hard drive is going to be between 0.5 and 0.7 megabytes per second in the Q depth of 1 random read speed. Now, solid-state drives can do random writes much faster than random reads because of the fact that they can take it into their internal buffer and then reorder it into something resembling a sequential write, and then write it to the flash memory much faster. But it can't do that when it doesn't know what's coming next, which is why the 1K Q depth random read is so much worse than the Q depth of 4 with 4 threads, which is 2 lines above it, which is 134 megabytes per second. But that is not a normal desktop application. It's really that bottom left-hand corner that you want to look at. Run this program on your own machine. Put it on your C drive. And by the way, this test was not run on a clean drive. This was run with Windows installed in the machine, which is actually a fair way to run it. Now, if I have 10 different drives, I test them cleanly without Windows in order to get as even comparison as possible. But if you test your C drive against this C drive, it's a pretty fair and reasonable comparison. If you are running a hard drive and wondering why it takes 30 seconds to a minute to open your web browser rather than half a second, if you're wondering why it takes 30 seconds to a minute instead of 10 seconds to boot up your computer, that's why right there. Next up, we have Cinebench, the 3 animation benchmark. Cinebench scales nearly perfectly with n number of cores, and it really loves Ryzen processors, which is why AMD loves to feature it so much. Now, we have 1,243 points on this CPU, as I said before, running at stock speeds, which means that the cores are really running at 3.7 gigahertz in this test. Now, if you overclock this CPU to 4 gigahertz, how much extra performance do you get? About 100 points. It'll run about 1340, 1330, somewhere in there on the multi-threaded Cinebench result. I would like to make a point, however. You're spending about $230, $240 to buy a Ryzen 5 1600X. You're spending $40 to $50 on a nice 120 millimeter liquid cooler or a tower cooler to be able to overclock to 4 gigahertz. So you're spending somewhere in the $270 to $280 range for the CPU plus cooler. For about $20 to $30 more, you can buy a Ryzen 7 1700, and it comes with a cooler. It comes with an RGB version of this cooler. Now, if you really care about multi-threaded performance, I'd like to point out that for a very small amount of money, a Ryzen 7 1700, completely bone stock, not overclocked in any way, does about 1450 in Cinebench multi-threaded. Overclock it to 3.7, and you'll be around 1600. Overclock it to 4.0, and you'll be at about 1750. So if multi-threaded performance is actually important to you, if you're doing workloads where you care about that result, you really should be on a Ryzen 7. It makes absolute total sense to just get that. Now, it won't run at 4 gigahertz on the included Wraithspire cooler, but both of my Ryzen 7 1700s will run absolutely fine at 3.7 fixed, getting you about 1600 or so points, which completely blows away anything the Ryzen 5s will do. Next, we have SevenZip's built-in benchmark. SevenZip is a file compression, decompression utility, and it's useful for seeing several aspects of our system's performance. This is one of the most memory speed dependent tests that I run on any of my various benchmarks and tests and analysis. Going from DDR4 2400 to 2666 to 2933 to 3200 actually shows a difference in this test. How much so? DDR4 2400 to DDR4 3200 has about a 9% performance difference in this test. It's the one really big place where it shows. In previous videos, I've talked about RAM speed really only mattering for file compression, decompression, software compiling, doing virtual machines where a lot of memory accesses are happening. Almost everything else, it's not that big a deal. Video rendering, it helps a little bit, but we're talking closer to 3 or 4% there. So spending a ton of money to get super fast RAM is not as important for the average person as it is to somebody doing this. Now we have nearly 32,000 million instructions per second. That's actually pretty impressive. However, this is a multi-threaded test, and this kind of workload is, again, just like the Cinebench test, totally focused on how many threads and how many cores you have. If you do file compression and decompression rarely, this doesn't matter. You know, if it takes a couple of extra minutes and you do it once a week, really, who cares? But if it's something that you do often, or you do workloads related to this, a lot of file moving around, a lot of file reading and writing of compressed or encrypted files, then multi-threaded performance might be important to you. Again, let me give you a simple comparison. Ryzen 7 bone stock will do over 36,000 in this test. Ryzen 7 1700 overclocked to 3.7 gigahertz. Again, it does it on the included cooler, only about $20 or $30 more than this setup. 41,000. 9,000 points more because it scales almost perfectly with all the extra cores and threads. If you the whole takeaway from this, if you care about multi-threaded performance, if the fact that you're running programs that uses all your cores and all your threads, video encoding, file compression, decompression, video 3D animation, if you're doing that kind of stuff, Ryzen 7 or bust. Really, you shouldn't be looking at anything else. For the average person, Ryzen 5 1600 is really the sweet spot of price to performance. The next benchmark I'm going to show you, I have to bring up full screen because there's so much information on the page, but it's 3DMark's Time Spy. This is the only not free benchmark in this result, but if you have a copy of 3DMark, run it on your own machine and compare it here. Now, this particular benchmark is far more testing the video card, not this one, the RX 570 that's in the machine, than it is the CPU. The physics test, the third part of this test, does test the CPU, but the majority of this is actually testing the video card. I would like to point out that the CPU is running basically in single core mode for the first two parts of this test because it monitors the clock speed, and it's running at either 4.0 or 4.1 gigahertz. It's only in the physics test that it slows down to 3.7. Now, you will get a very similar speed to what you're about to see if you put in a GTX 1063 gig card instead of the RX 574 gig card, which isn't currently available in September when I'm filming this at anything approaching a reasonable price. It's just what we had to put into the machine. All right, here's the results. And here you can see 3960 total points. Again, that score doesn't mean anything. You have to run it on your own machine for that number to mean anything. Notice the validation warning in the middle. That is because I have the absolute latest and greatest driver installed from AMD for the RX 570. It's not currently recognized by 3DMark. Don't worry about it, but I have it expanded so you can see it so you know what's going on. I also have this page full screen because I want you to see the details. You can see everything about the system components in the actual run, as well as the individual scores, the two graphics scores, as well as the CPU score. Notice the CPU score is much higher than the graphics score. The CPU in this computer is a little overpowered for the graphics card. You're going to be graphics card bound in almost everything that you do on this machine if you're using the graphics card. If you're playing games, if you're doing 3D animation, the graphics card is going to hold you back. But it's, again, what we had to put in the machine, so there you go. This next benchmark that I'm going to show you is awesome. First of all, it is finally a free download, and you can download this and run this on your own machine. It does take between 20 to 30 minutes to run, I will caution you. But the reason for that is because it tests Office application performance, video conferencing, app startup and shutdown, web browsing performance. It does do a little bit of image editing, image resizing, scaling, a little bit, not a lot, but a little bit of video encoding performance and animation performance. So it's testing a wide variety of desktop applications on your machine, which is why it takes 20 to 30 minutes to run. So I'm going to bring up two different slides here and then talk about them in detail. Here you can see the first slide. We have a total PC Mark 10 score of 5,093 points. And you'll notice that it says valid score because it's fully updated. This didn't particularly care about the driver, or perhaps it's a more updated version, but it was fully validated. Notice that I clicked the detailed score button so you can see each individual score. Here's why this is so important. That big score at the top is often the only number reported. Run this on your own machine. You may not care about the photo editing or the video editing score. Maybe you only care about the app startup or the video conferencing or the web browsing score. So you can test your machine and only compare the scores that you care about rather than just the total overall score. At the bottom, you can see that I have gone ahead and included the full system details, so you can see all the pieces of the computer, you can see the RAM, the storage, the graphics card, all the details to compare it not just to how the system was built, but also to your own machine. Now that's it for the benchmarks in this video, but I am going to talk a little bit more about should you upgrade and is it worth it, because those questions get asked all the time, so I want to address those two questions right now. The first question is, should you upgrade? I get asked this all the time in the comments beneath my videos. People tweet it to me on Twitter. They say, I have XYZ processor, should I upgrade? I don't know, should you? And I'm being serious with that response, because the question is, what do you do with your computer? Is your computer running slowly? Are you finding that you sit down to use your computer and it's sluggish, or it takes a long time to do what you're trying to do? Because if the answer is no to any of that, if you sit down and your computer's quick and responsive, why upgrade? My argument now is, does my computer do everything I need it to do? If it doesn't, time to throw some money at it. If it does, keep it. Let me give you a simple example. i5 2400. It is a 6-plus-year-old CPU dating from 2011. I have made several videos about the deals of those CPUs and the pre-built systems on eBay in the past. I still have one. They're great machines. If you are just web browsing, watching videos on YouTube, opening a Microsoft Word document, running Skype occasionally, playing League of Legends or World of Tanks, do you need a Ryzen 5 1600? Absolutely not. A 6-year-old i5 2400 with a $100 RX 560 or GTX 1050 will do all of that perfectly well. What does that machine really need? 8 or 16 gigs of RAM, depending upon how much you multitask, and a solid-state boot drive. That will change that machine dramatically. Putting a solid-state drive in an older computer will often make it feel faster than a CPU upgrade will. Now, if you already have one and you want it to be faster, that's a separate topic. But if you are happy with your computer's performance and you're not putting a lot of demand on it, all of these shiny new CPUs may be overkill. On the other hand, if you're finding your games are running slower, maybe you want to edit your holiday videos, perhaps you want to multitask some more, you just want your computer to be snappier, quicker, and more responsive, and you want it to wait for you instead of you wait for it, Ryzen 5 1600 is incredible value for the money. Now the second question is it worth upgrading? I perhaps get that one even more. Is it worth buying a Ryzen 5 1600? Is it worth buying a whatever? Now that's a challenging one because very rarely is that question asked with enough detail to give an intelligent answer to. What do you have now? What are you running? Why do you want to upgrade? And what do you hope to accomplish with the new CPU? For example, if somebody's computer is really sluggish when you're multitasking, you've only got 4 or 8 gigs of RAM, and you're running off of a hard drive, a faster CPU will not make the machine faster. You need more RAM or a solid-state drive, and it will make an older machine very snappy and responsive in those particular cases. On the other hand, if you already have a solid-state drive and 16 gigs of RAM in a 5 or 6-year-old computer and you're trying to edit 4K video for YouTube, that's not going to work out very well. Now, is it worth it is very subjective. Do I find it worth upgrading an older, say, i5 2400 to a Ryzen 5 1600 for a basic office machine? No, I don't. And even with more powerful machines, I still have several i5s around the house, specifically my kids' machines, that I simply have no interest in upgrading because they do everything that I need. On the other hand, if I want to edit 4K video, a 4-thread machine is not going to cut it. In fact, the reason I built my i7 6800K last year was because a 4-core 8-thread machine could not handle 4K 60 frame per second video in the edit mode. Of course, for the rendering part, Even an i5-2400 will render 4K video. It's the editing part, scrubbing through the timeline, processing it, and trying to put in edits that you actually do need real-time performance. When I upgraded to 6 cores, 12 threads, that changed things dramatically. Then, earlier this year, I upgraded to Ryzen 7 1700, and it was wonderful, yet again, it changed how I use the machine. But most people don't do that. I mean, be honest with yourself. Do you really edit 4K video on a regular basis? Probably not. Now, if you do have, for example, even a cell phone that takes 4K video, and you edit it occasionally, you may find that a Ryzen 5 1600 is the perfect balance of price to performance to give you smooth editing performance and very respectable rendering performance. So your personal situation also determines, is it worth it? And that has to be taken into account when making an upgrade. Now, I make a living with my computer. I edit 4K video daily for YouTube. Behind me, that large tower, is my Skylake X 8-core 16-thread machine. That is a $4,000 computer back there. Is it worth it? For most of you, no. For me, absolutely. That renders video 25% faster than my Ryzen 7 1800X does. It is noticeably quicker and snappier in responsiveness when I'm doing 4K 60 frame per second video editing, especially when I'm working with multiple videos at once for like game performance videos and whatnot. But that is not a typical situation, and it would not be worth it to you, even though it's worth it to me. So to sum all of that up, should you upgrade your machine? What are you doing with your current one? Is it slow? And is the CPU the reason why it's slow? Or is it RAM, storage, or perhaps graphics card, which is another topic I won't even get into in this video? Is that why it's slow? And what's your budget, and can you reasonably afford this? Now, if you do have a 3, 5, or even 6 or 7-year-old machine, and you're happy with your storage, you're happy with your case, maybe it's a custom build, you have a decent power supply, motherboard, CPU, and RAM, because you will need new RAM if your system is more than about 3 years old or so, is not that expensive. About $200 or so for the Ryzen 5 1600, cooler included, about $100 for a motherboard, and about $100 to $150 for 16 gigs of RAM will give you incredible performance compared to a 3, 5, 6, or 7-year-old machine, if you need the cores. On the other hand, let me make one very clear exception to that statement. Do you have an older i7K chip, even going all the way back to an i7 2600K? Is it overclocked to say 4.2 or 4.5 gigahertz or beyond? Now, it's true that's only 4 cores, 8 threads. This is 6 cores, 12 threads. The reality is, for what the average person does with a computer, an i7 2600K at 4.5 gigahertz will be faster than a Ryzen 5 1600 at 3.7 gigahertz. Now, that's an older chip, and its per-core speed is not as good as this, but the 4.5 gigahertz makes up for it. A locked chip will be slower and won't necessarily follow that rule, but the K chips, if you've got it overclocked, will. I only make that point because core count and clock speed are two different things, another topic I won't get into in this video, but I want you to be aware of the fact that the clock speed here is lower than Intel has had overclocked chips now for quite some time. So if you have one of those, this might not be the upgrade. In fact, the upcoming Intel Coffee Lake 8th generation chip might be a better upgrade if you're coming from an existing K chip in the Intel line. I hope this video has been helpful and useful to you. Be sure to like the video if you like it, share it with your friends if you loved it. Remember to subscribe to my channel with the big huge button down below. Questions and comments in the comment section. Please check out the links in the video description. Links to Amazon and Newegg for all the parts in the system. Link to the giveaway for this machine, not up for much longer, so be sure you enter. If you're watching this in October or later, well, I'm sorry, the giveaway is over, but if you're watching this in September, be sure to enter. Thank you all so much for watching. I will see you in my next video.